Question 12.2, and let's take a look at this example. Does the amount of education play a role in the healthiness of an individual? The following data represent the level of health and the highest degree earned for a simple random sample of individuals from the General Social Survey. Does the evidence suggest that health and education are related? Use the alpha equals 0.05 level of significance. Okay, so first of all, we're going to state the null and alternative hypotheses. So for these types of tests, we'll look for some keywords. We're seeing play a role. We're seeing the word related. These are kind of indicating that we should do a chi-square test for independence to see if there's a relation between the row and column variable in the contingency table. So for those, your null hypothesis is always that the variables are independent. So we will name the variables. So H naught, we can say something like health and education are independent. Meaning there's no connection, there's no relationship between them. And your H1, which is the suspicion here, is that there is some sort of relationship. So we can say health and education are dependent. You could use the word related, you could use the word associated. I'm going to say dependent, but those all mean the same thing. So we want to enter this data into the calculator. Because it's a two-way table, we'll need to do that using a matrix. So you'll see in your calculator above this X inverse button, there's the word matrix. So we're going to go into that menu. So second, X inverse. And we want to edit matrix A, so we can enter this data in there. So go to matrix A and press enter. And now we need to tell the calculator the size of the matrix. So the first number is the number of rows. So we have 1, 2, 3, 4, 5 rows. The second number is the number of columns, and we have 1, 2, 3, 4 columns. And now the matrix is the size to fit the data in the table, so you type in row by row. So if 72, 202, 199, 62, now we're on the second row, 465, 877, 358, 108. Next row, 80, 138, 49, 11. Next row, 229, 276, 64, 12. And last row, graduate degree, 130, 147, 32, 2. Okay, once you have entered your data into the matrix, you can go to your chi-square test. So we'll go to Stat, arrow across the top to Tests, and the chi-square test is way down there, so I'm going to press up, go up from the bottom, there it is, chi-square test. So press enter. You never have to change these. So what's going to happen is it's going to look at matrix A for your data, and it will populate matrix B with the expected counts in case you need them or want to look at them. All you need to do is go to calculate to get the p-value. And there it is. So you'll see that this one's in scientific notation. This is the test statistic here, and the p-value is so small that it's in scientific notation. It's actually 6.39 times 10 to the negative 54 power, which means it's 0. And then 53 zeros and then a 6. So that is so tiny that if we wanted to round it to 3 decimal places, it would actually round down to 0. So the p-value is approximately equal to 0, but I'll put a note here. It was 6.39 times 10 to the negative 54, which if you round to 3 decimal places is 0. So the question is, do you reject H naught? Well, yeah, this p-value was extremely small. It was certainly less than alpha. So do we reject H naught? Yes. We have very strong evidence to show that health and education are dependent. In other words, if they were independent, it would be extremely unlikely to get this data. So unlikely that we reject H naught. So we can state our conclusion. There is sufficient evidence to conclude that health and education are dependent, are related, are associated, all are synonyms. Okay, so let's try another one. It's asked in a slightly different way. Celebrex, a drug manufactured by Pfizer Inc., is used to relieve symptoms associated with osteoarthritis and rheumatoid arthritis. In clinical trials of the medication, some subjects reported dizziness as a side effect. The researchers wanted to discover whether the proportion of subjects taking Celebrex who reported dizziness as a side effect differed significantly from that for other treatment groups. The following data were collected. Test whether the proportion of subjects within each treatment group who experience dizziness are the same at the alpha equals 0.01 level of significance. So there's a couple of key words here as well. I'm seeing the word proportion showing up here, also here, the word same, the word differed. So because we're seeing the word proportion appear, we're going to treat this one as the test for the homogeneity of proportions. It is similar to the test for independence. The only real difference is the way you write your hypotheses. So when we write our hypotheses, we're going to notice that we're looking at 1, 2, 3, 4, 5 different populations. So we're testing the equality of 5 different population proportions. P1 equals P2 equals P3 equals P4 equals P5. And then for your alternative, you're going to say at least one population proportion is different from the others. And you really need to say it this way. It's the minimum for not all 5 being equal, is at least one is different. So 4 could be equal, but 1 could be different. And that would violate H naught. At least one population proportion is different from the others. Okay, so the way we find the p-value is exactly the same way as we did for the last problem. We do need to edit a matrix, so let's go back in, second, X inverse, edit, enter. So first of all, we need to change the size of the matrix. This matrix only has 2 rows, and it has 5 columns. So now we've changed the size of the matrix, and we can type in the data values. So we'll go across the top row, 83, 32, 36, 5, 8. Now the next row, 4,063, 1,832, 1,330, 382, 337. Okay, and once you've entered the data from your contingency table into the matrix, you can do the chi-square test. So it's the same test we did in the last example, stat, test. Let me go up to letter C, chi-square test. And then you never need to change these things. They can stay the same. Just go to calculate and press enter. And here we have a p-value. So if we're going to round that to 3 places, it's about 0.323. So let's write it down. P is approximately equal to 0.323. Okay, so what was our level of significance? 0.01. So in this example, P is greater than alpha, which means our results are not statistically significant. They do not cause us to reject H naught. So do not reject H naught. Okay, so we will say there is not sufficient evidence. And here's our conclusion. There is not sufficient evidence to conclude that. Now we could state this a couple different ways. We could say at least one population proportion is different from the others. We could say something like proportion of subjects differed significantly. Let's go with our alternative that at least one population proportion, let's add some details, of subjects who experienced dizziness as a side effect is different from the others. More than one way to do this. This is just what I'm going to go with. Okay, so for part B, I added something in here. It says find the expected counts. Of course, there is a way to do that by hand. It takes a long time. The good news is that once you do a chi-square test, your calculator will populate matrix B with the expected counts for you in case you need them for some reason. So if I want to find the expected counts, meaning the numbers we would expect in the table if the proportions were equal, we can get that from matrix B. So go back into your matrix editing menu, second, X inverse, go over to edit, and then arrow down to matrix B and press enter. And now we can look at matrix B. So you can scroll through matrix B and see all of the numbers. Let's go ahead and write them down in the table. I'll just do 1 decimal place. So if the proportions were equal, these are the numbers we would have expected to get in the table. So for Celebrex, 83.9, 4062.1. We may desire to look at these to compare them to the actual counts. Might be of interest to look at. So I'm just copying down the numbers that I see in the table. I'm rounding to one place. I'm going to arrow over to see more. So a couple more. Okay, ibuprofen. We'll round that up actually. Round that up to 7. Okay, so what you can do is, I'm going to scroll out a little bit, or zoom out, is we found out that our results were not statistically significant, which means that even though these numbers you can see are different, they're not different enough to be considered compelling evidence. And if you take a look across the table, some of them are quite similar, which is maybe why our results ended up with a high p-value. None of these numbers are really off by a lot. Maybe the naproxen numbers are a little bit different, but overall you can see no really huge changes from the observed counts to the expected counts, nothing really striking. So that might be a reason to look at the expected counts if you want to see how off or how different they are. But these kind of make sense. None of them are really way far off to call into question our p-value. Okay, so let's try one more example. In a recent survey conducted by the Pew Research Center, a random sample of adults 18 years of age or older living in the continental United States was asked their reaction to the word capitalism. In addition, the individuals were asked to disclose which political party they most associate with. Results of the survey are given in the table. Does the evidence suggest individuals within each political party react differently to the word capitalism? Use the alpha equals 0.05 level of significance. Okay, so it's a two-way table, meaning it could be a test for independence or a homogeneity of proportions. I see the word individuals within each affiliation react differently, which is making me lean towards using the test for the homogeneity of proportions. So let's start off with our hypotheses. Here we're looking at 3 populations, Democrats, Independents, and Republicans. So we're testing the equality of 3 proportions. H1 is always the same. At least one population proportion is different from the others. And then H1 kind of corresponds to the question, do the individuals react differently within each political affiliation? So let's go ahead and enter these values into our matrix. So second X inverse, and we go over to edit, and then matrix A. We will have to change the size. There are 2 rows again, but this time only 3 columns. And let's enter in the numbers first for the positive association for the word capitalism. 235, 288, 256, Now, a negative association to the word capitalism, 264, 266, 157. And then looking at the raw numbers can sometimes be difficult because you can see that they didn't get the same amount of each political party. So even though the numbers can be compared, it's not as really accurate as comparing proportions, which is why we have the calculator do the test, right? It looks at all the numbers in relation to each other proportion-wise. Okay, so now we've finished the matrix. Let's go to our SAT tests. And I'm going to go to the chi-square test. And these can stay the same. We'll go down to calculate to get the p-value. Okay, so this is quite a low p-value. You can see because it's in scientific notation. I'm going to write it out in standard notation. P is approximately equal to 0.00003. So because of the e negative 5, I just moved the decimal 5 places to the left. That is a very, very small p-value. It's certainly less than alpha. So this is some pretty strong evidence, definitely strong enough to reject H0. Probably something you would have suspected that people of different political affiliations respond different ways to the word capitalism. There's a problem, I think, on your homework that uses the word socialism in the same type of example. Okay, so let's go ahead and write a conclusion. There is sufficient evidence to conclude that, and I'm going to restate part of this question here because I think it says it a little bit more eloquently than I would have written it myself. To conclude that individuals within each political affiliation reacts differently to the word capitalism.